In a world where people make a lot of money creating imaginary people and imaginary places, comes a very real story about hard work and struggle. That's right, not premieres or parties. No, this is the Klio Kast, an epic, wild tale of set life and paperwork. For producers, by producers. Hold on to your seat.
Okay. Hi, everyone. Welcome to the first rendition of Klio Kast, which is a podcast hosted by me, Adrienne Camille Lunson, where we talk about very specific industry things for the entertainment industry. But the first and most important question for what's going on right now in the world is, of course, COVID-19. I don't know, have you heard of this thing? Is it?
It's news to me.
I hope not. What happened to COVID 1 through 18? Like, do we just skip those prequels?
Oh, don't get me started. Don't get me started.
Well, let me introduce my two wonderful guests. We have Dr. Baum and Mr. Gunawardana. May I call you Manji?
That's fine.
Okay. He's the head scientist at the award-winning Oak Crest research facility here in Los Angeles, aka Pasadena. And we have another follower now watching. There's a couple people who will be popping in, and when you hear that sound, it's people who are enjoying what we're putting out there. So I'm going to turn that down. All right. So, fellas, give us an overview of what COVID-19 is, and if you wouldn't mind putting it in terms of viruses and diseases that people are more common, understand in a more common fashion. Like, people understand what the flu is, I think, and what a cold is, have a better idea of what HIV is versus and herpes is than this brand new virus that has a lot of misinformation going on. So if you wouldn't mind, just what is COVID-19?
Right, well, I'll start and answer your question first, and then Manji can jump in. First of all, thank you for inviting us, and it's great to be here with you. I think that informing the general public with scientifically correct information is critical to help us understand what this really is. So with that in mind, the disease that we all have heard about a lot is called COVID-19. It's a syndrome. In other words, it is a symptomatic disorder that one experiences if one is infected with a virus that is called SARS-CoV-2. And the reason it's called SARS-CoV-2 instead of SARS-CoV-1 is because it's the second coronavirus that has had widespread infection among humans. So the first one was an epidemic, this one's a pandemic. So coronaviruses are very difficult to actually put into context within what we're used to because they are so different. They are, and I'm sure you guys have heard it on the news a lot, the novel coronavirus. It is really a novel class of family of viruses as far as we humans are concerned. The viruses themselves have been around for a long time, but they typically only infect bats and other mammals that are in contact with bats. And as we kind of push back the environment and start to populate areas that used to be off limits, our interaction with the wild has become more pervasive, and therefore we're becoming more commonly infected with some of these viruses that may have been around for thousands of years, but we have not really gotten into contact. So coronaviruses are transmitted mostly by the respiratory tract, so through your nose or through your mouth, down into your throat and lungs. And they typically tend to target a certain receptor that you have in certain parts of your body. And they're unique in that sense compared to, say, HIV, herpes, and some of the other viruses, and also the flu. There are similarities between coronaviruses and the flu influenza virus in terms of the symptoms that you experience, at least at the beginning, because they're respiratory, right? They expand and infect in your lungs. And that is where the symptomology begins. But then they're very, very different in many ways as well. Strangely enough, the common cold is a catch-all for lots of different viruses. And we do have, they say, between 20 and 30% of common cold is a coronavirus of some sort that's been around for a while. So when I said that we've not been in contact with them, it's not strictly true, and we don't really know very much about them. But technically speaking, as a family, the coronaviruses are fairly unique. So that's kind of the sort of high-level overview. Manju, you want to add something to that?
Yeah, just to add on what Marc was talking about, the similarities and the differences. If you are familiar with the flu, the infection, you start infecting another person maybe about 1 to 2 days after you have gotten yourself infected. And then you are going to recover. But with corona, it has a longer incubation time. So it would be going from about 2 days to 2 weeks. And your infection time frame is longer. So that affects the population, because one person who's sick could be infecting many more people compared to somebody who was infected with the flu virus.
If I get this straight, so what COVID-19 is referring to is a group of symptoms that is caused by this SARS-CoV-2?
Yes.
And it's the second time. The first one was an epidemic. Was that the swine flu? Like, what was number one? Like, how did we miss the prequel?
So the first one was actually called SARS. We had another one called MERS. That's also coronavirus. That one didn't come from bats. That one came from camels. But they are similar. The one thing that's maybe a little unusual about this particular one, SARS-CoV-2, is that it is genetically, the sequence of the virus is genetically very, very different from the others. It clusters very differently. If you imagine a sort of phylogenetic tree, over 20% of the genome in SARS-CoV-2 is different from SARS-CoV-1, which is much more similar to MERS. So it is kind of a genetic outlier, if you want to look at it that way. And it just so happens that most coronaviruses are not transmissible from bats to other species. And this one is just an unfortunate one that managed to kind of hop across species.
I think unfortunate is
It's an understatement.
It's an understatement, a little bit of an understatement. So it just kind of ended up being a perfect storm of a virus that we were not familiar with, that genetically hopped from one species to another, is highly contagious without the person being knowing that they're contagious. Along the line, I'm guessing the way you can have HIV, not know it, and spread, and then when you have AIDS, that's the showing of the disease. Kind of like you can have SARS-2, and then COVID-19 is it showing the symptoms, right?
Yeah, so your analogy is perfectly correct. So if you are HIV infected or infected with SARS-CoV-2, but don't develop a syndrome or a disease, you would just say you're infected with the virus. Once you start developing AIDS or developing COVID-19, you are fully fledged displaying the symptoms of the disease.
So if you have, let's say you contract it, you mentioned, I'm bringing this up because you mentioned it before to me in just a conversation, is that why it stays in your body for so long before either showing symptoms, and is it the whole time it's in your body that you can spread it, or do you have to get to a certain incubation level? Is it another stage? Can it just be in your body and you not pass it on to anybody? How does that work?
So I'll take a stab of it, and then I'll let Manji elaborate. So the one common thing about all the questions you're going to be asking us regarding to COVID-19 and the associated virus, my answer probably will be the same in the sense that we don't know. That is the common thread. There's so much that we're learning, and we've learned an incredible amount in the last 6 months, but we still don't know a lot. The other thing I will tell you is that even when we do know certain things, there are no certainties. And that is the one thing that is the hallmark of this virus, is it is so heterogeneous in terms of predictability in infected individuals. It's so hard to know how they're going to respond, how they're going to respond to treatment, how they're going to be in terms of being infectious, etc. In classical virology, you typically need to have, as you said before, a highly infectious virus. That's why it's been so successful at spreading this pandemic. It's got the perfect combination of infectivity, it's highly infectious, and it gives you severe symptoms, but not severe enough to kill everybody off right away. So it's like Ebola is highly infectious, but also has an incredibly high mortality rate. So Ebola outbreaks typically don't last very long.
Right.
With
It was
SARS-CoV,
wasn't that also what happened during the Spanish flu, and that's the big difference between the Spanish flu and this flu, that if someone say got infected in the morning, by evening time their whole family would be dead?
right. So the Spanish flu was definitely more deadly. If it was more deadly because we didn't have as good a way of treating people that back then as we do now, we also didn't have the molecular biology to be able to do testing quickly, et cetera, et cetera. So I think there are many different reasons. I think the Spanish flu typically was more, had a higher mortality rate associated with it. I'm not sure if you put them side by side, how much worse it would be compared to Corona today, just because of how much medicine has improved since the early 1900s. But basically, the things we do know is that, and the different reports will give you different statistics, but the message is the same, and that is that a very high percentage of people who are infected with SARS-CoV-2 do not display symptoms. That is, they remain asymptomatic. So they never develop what we would call COVID-19, even though they are positive for the virus. They, at that point, you could ask, are they infectious? Because that's the worst possible scenario. Are they spreading without knowing it? And the answer is yes. There are numerous studies that show that asymptomatic carriers can be infectious, and they even have a name for them. They're called silent spreaders. So we do know these two things. When do they become infectious? I think that there is definitely, as Manji said, it can be a slow incubation period, and you need to build up a certain amount of virus in the fluids that you expel when you're coughing or sneezing or talking or singing, that have a high enough load of virus for the virus to be able to infect. Typically in virology, you have what's called a minimum infectious dose, right? A dose below which, even if the virus is there, it's probably too low to infect you. That's a rule of thumb. It's not an absolute. And there have been some studies, very basic ones, where they looked and said, okay, how much virus do you need per cough to be infectious? And I would not hold too much stock in those numbers. They're an interesting number to discuss, but I don't think that they really are helpful, because in theory, with such a highly infectious virus, you could be infectious with a very low load, or you get exposed to very high load. Another thing that's unique or fairly unique with SARS-CoV-2 is that you tend to have in your lungs, throat, and nose very, very high titers of the virus. That is different from, say, the flu, where typically the titers are much lower. So you have, billions and billions of viral particles.
Real quick, what did you say? You have large amounts of what's in your throat and lung and
viral titers. So this is just a way of saying the number of viral particles, the number of virions.
Okay, it's how you count itsy bitsy things.
Exactly. So say, for example, if you were to put them out on a slide and go through with a microscope and count the virus particles, and you say, I've got 150 million viruses here in this sample, that's your viral titer, the copies. And so you can have in just one nasal swab, and we've all seen those in the news when people go to get sampled. They either get an oral swab or a nasal swab. The swab is pretty much the same type of swab. It's like a Q-tip. If you collect it from someone who is just about maybe to develop symptoms, maybe like Manji said, around the 4th or 5th day after having caught the virus, when it's really replicating quickly, there are cases, lots of them, where one of these swabs, just taking a swab of the inside of your nose, you're not collecting a lot of fluid. That swab could contain about 100 million virus particles. It is uncanny. I mean, it's an incredibly large amount. So that person, if that person were to cough on you, you would most likely get the virus. And that's part of the reason why it's spreading so quickly.
What if
And
that, what if that
I
person
know.
just breathed in your general area?
So that's a
Vicinity.
really good question. That's a really good question because that's one thing that is maybe not getting enough coverage in the media. So everybody's talking about masks, and the main reason to wear a mask, as we all have heard, is to protect others from you, right? You're the emitter, and by putting a mask on, you're preventing yourself from emitting virus. It's kind of like your car and your catalytic converter. You're not scrubbing the air around you with your catalytic converter. You're spreading the emissions from your car from reaching the environment. So masks are extremely effective at doing this. Having said that, when you are just breathing, if you're just breathing normally, there's very little in terms of droplets that are being emitted from your nose and mouth. It really only starts when you're talking. And there's some very interesting videos online and by the NIH where they've done measurements on this. Basically, when you talk at a low voice, you emit much less virus than if you're shouting. And if you're singing, it's pretty much the worst case scenario in terms of emissions. So it's very dependent on how you talk and what you say. So for example, if you want to, if you're walking by someone and for whatever reason that person doesn't have a mask, you would ask them to please not say anything because then they're very unlikely to be spreading virus your way, even if they're not wearing a mask. And that's the thing is that, I know we're social beings and we like to say good morning or whatever to each other. The best thing we could do is not say anything to one another when we're out in public, because that would really make a difference in terms of how much virus we're throwing out there. Manjula, I don't know if you want to add to that.
I would add to the beginning of the topic on this question is viral particles are opportunistic. So they want to use the host the COVID-related host is the human. You don't want to kill the host too early because the viral particles have to replicate and they need to spread. So the difference between SARS-2 and SARS-1 was the SARS-1 was the mortality rate was about 30%. So you're talking about more than 10-fold difference between the mortality rate. That means the virus would replicate the SARS-1 in the human, and it would the human would be diseased before it can spread to more people. So COVID-19 or SARS-2, it's like ideal virus. It's making you sick, but at the same time, it is making you spread to other people as well.
So SARS-2 is the sequel with Dr. Evil, with a more evil villain that waits longer. So it's more like Alien and then Aliens, where they infect the host, they leave the host alone for a little while, and then it just explodes out of your chest, kills you, and then goes after your friends.
There you go. That's one way to put it.
A better way of describing it. It just okay. Was there anything else, Manju, you wanted to add to that?
And that's it.
Okay, so since we started in on some of the testing, there's lots of stuff going on that, and not a lot of very specific things. I know we've talked about what you found, what the tests you do, what are the different kinds of tests, and what are the accuracy. I do know that there are people out there who are hoping that there's going to be an instant test very soon. So different tests, accuracy, what would you recommend?
I mean, I think that first and foremost, testing is absolutely instrumental to managing this disease. What we can argue whether or not there will be a vaccine soon. We can argue whether or not there will be a therapeutic soon. But in the meantime and in the foreseeable future, there are the key guidelines that you see from the CDC, the 5 major guidelines that they give you in terms of how to minimize the spread of the virus. They're all good, but as far as I'm concerned, the best one, if you can do it, is testing, because knowing your status allows you to make informed decisions about what you do and allows you to remain productive if you don't have it, rather than having to quarantine for no reason, right? So testing is absolutely instrumental in my mind and is the key to being able to weather the storm here. And one of the reasons why we're doing such intense testing at our home institute. Having said that, not all tests are the same, and you alluded to that, and I agree with you. I think that there is a CDC molecular test where you're looking for specific genetic material that is part of the virus, and which is called RNA. So the virus is an RNA virus, so it doesn't have actually any DNA. And so where the virus is, there will be viral RNA. So that is the kind of the gold standard, is to say, if you have the virus, we should be able to detect viral RNA. And there are different platforms to do this. The gold standard, again, is there are 2 major kind of tests out there. There's the WHO test, which is more the international one, and there's the CDC one, which is slightly different. But overall, they are looking for different genetic pieces within the genome of the SARS-CoV-2 virus. But that's what we're looking for. And then there's a way of running the test and an instrument that you use to get a readout on the test. Those are all fairly well prescribed. And there is a bit of a human element. I mean, not all labs are getting equally good results in terms of false positives, false negatives, how stringent your quality controls are, etc. If you're a clinical lab and you're trying to run thousands of tests a day, or if you're a research lab like we are and you're doing just 20 or 30 tests a day, then it makes a huge difference in terms of the amount of additional work you can do to make sure that your tests are valid. So it is a very gray area. There's a lot of variability. There's some labs that report pretty awful success rates in terms of confidence rates that aren't inspiring. Where you have false negatives, which are the worst, right? Because if you're positive but you get a negative result, then you potentially are running around spreading it to a bunch of people because you think you're safe, and that's probably the scenario that we want the least. And there are some reports of false negatives between 5 and 10%, maybe even higher than that, with this molecular test, which is concerning. It shouldn't be that high. And then you have false positives, where you basically are negative, but you have a positive result. That may cause you a lot of stress and may cause you to self-quarantine for 2 weeks unnecessarily, but it's not as bad as spreading the virus to other people without knowing it. So that's kind of the framework for the molecular test. Then there is the antibody test that we've heard a lot about. And there's 2 main branches of that. There is an antibody test where you're taking human blood and you're looking in the blood for a human antibody that was produced by the host in response to having been in the past infected by the virus. So I catch the virus, I do or I don't develop symptoms, my body recognizes that there is something going on, it mounts an immune response, generates antibodies to the virus, and we can measure and detect those. That's one test. The other test is where you look specifically for proteins of the virus. So you're not looking for a human response to the virus, you're using antibodies that recognize pieces of the virus. And that, I believe, is what the home at-home kit is going to be, because if you're looking for antibodies that you've produced to the virus, the ship has sailed, right? It's too late to take action. It's only good to know, did I get it, or did I have it? When I was sick 2 weeks ago, did I have COVID or did I have the flu? And there's another whole discussion on antibodies, but basically that's
Right.
kind of
And then as some of the antibody tests, they think that there's one for you currently have it and one that you used to have it.
right. So
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 I
now
feel like this
we're
is a
getting the weeds here. We're getting the weeds.
well,
So
no, I'm just curious.
no, it's actually very important because the information that is out there can be confusing because there's so much of it. So first and foremost, I have to say that as a scientist, and Manji knows way more about this than I do because he's a molecular biologist and he actually runs those assays at the bench. I'm a chemist, so it's not my area of expertise. But typically, the antibody tests that you would get commercially have primarily been developed to be clinical tests. So that's where they're needed right now. They're not research grade. What I mean by that is for a clinical test, all you really care about is do I or don't I have the antibodies? You don't really care how much and how accurate the how much is. As scientists, we do. We want to know exactly how many antibodies per milliliter of blood do you have, because that can tell us a lot of other things. But for a clinical test, you don't need that. And so most of the clinical tests were developed with that in mind. They were basically developed to be yes or no, not highly quantitative. And the key was that you don't get fooled by antibodies that were developed in response to a cold or a flu or something else, so that they're selective. Even then, for the most part, there's some newer ones that have come online maybe the last month or two, that are better, but they were for a long time not very good, and there were a lot of recalls. I'm sure you heard in the news in Europe that they ordered a whole bunch of different antibody tests and had to all send them back because they didn't work. So there's been a lot of controversy around the antibody test. The one that they're working on for being able to detect, do you actually have COVID-19 right now, or are you infected with the virus, by looking for the virus proteins in, say, a nasal sample. So you can do this at home, like a pregnancy test. Those are not going to be very quantitative, but because they're also not going to be very particularly sensitive, but because, as I said before, the higher the amount of virus that you have in your nose or in your throat, the more infectious you're going to be. It can be very useful, right? Because even if it's not particularly sensitive, if you're kind of at the end of your infection and you don't have a lot of virus in your nose, maybe you're not infectious at that point. And maybe then you would be a negative with this new test. But if you're highly infectious, there's a very good chance that that test will tell you that you're positive. So that at-home test has the potential of doing a lot of good and allowing people to kind of monitor themselves and manage themselves in terms of how they interact with family members and outside of the home. So these are all, very, very important.
And
Imagine you want to say something more since you're the guy who actually knows how to run those tests.
I don't want to put some of the tests in a bad light, but what Marc was talking about, the quantification and qualification. So the clinical tests, they are qualifying you yes or no, and some of the antibodies that are you being analyzing for, they could have some similarities with certain other viral particles as well. So at least the initial assays that we had access to, there could be ambiguity on the result. Was it like really the SARS-2 or a related virus? So I don't want to put too much doubt on it, but that's why personally I would go with the PCR assay commonly known, because you look for two separate areas of a certain gene in the virus. And you can even increase the efficacy, the stringency of it by adding another region if you want to put 3 regions in there. So your confidence level increases with that assay looking exactly for the SARS-2 virus.
So the reason I bring it up is because and I'm being really specific and getting in the weeds on this because for the entertainment industry to go back to work, for you to get to see your new favorite show and not be watching reruns for the next 2 years, we have to figure out how to get people back on set, and productions are very people oriented. There's no robotics. It's very old school. So you've got your people carrying lights, you've got your people doing makeup. And then on top of that, you have what I would refer to as high level assets. So your movie stars, your famous directors, how do we keep these high value assets, if you were, safe? And, you know, how often do we need to do testing? How much PPE? How do we mitigate risk? In the military, we had operational risk management. You just figure out the things that create risk and figure out how to minimize them as best as possible. And so, if testing is that important, doing correct testing, it would suck if you just were doing testing and it was totally the wrong tests and didn't mitigate risk at all.
Yeah, so that's a very practical question, right? In terms of how do we stay productive in certain areas during the whole COVID pandemic? So I think that there is an answer to this. It's not necessarily easy, but it can be done. So that's the good news, right? There is a way, and unfortunately, there may be simpler ways of doing it, but we're just not there yet with the simpler ways, scientifically speaking. So let me start with the simpler ones and why they don't work, and I'll work towards what I think, in my opinion, would work. And I think I have some pretty good evidence to support that, big and small. So, so first of all, there was the sort of antibody passport that people were talking about in Europe, especially Germany, to let people go back to work. You get the antibody test. If you have the antibodies, you're most likely immune. You won't get the virus again. You can go back to work. That we now don't think is going to work. And that won't work for two reasons. Number one, that we still don't have absolute proof, and you would need that for something like this because you're taking a huge chance otherwise, that the antibodies really indicate that you've developed immunity. So that we still don't know. And with coronaviruses, they have a history where immunity may not be very long lived. And so that is something that we need to be aware of and careful of, mindful of. The second thing is it is now becoming clear that the antibodies, the antibody that gives you memory to prior exposure to the virus, that allows you to mount an immune response if you're re-exposed again, those antibodies have a very short lifetime. There was a study out of UCLA, our collaborator, Otto Yang, and others, but they published it just a few weeks ago in the New England Journal of Medicine. And they found that on average, it was very heterogeneous among individuals, but still they were able to tease out a half-life of about 35 days for the memory, the IgG, which are the antibodies that have the memory. So imagine that within 35 days, your antibody concentration goes down by half. So you guess that within maybe 3 to 6 months, you may have lost your immunity, if that is really indicative of immunity. Which is actually ironically, or maybe not so ironic, there was a paper published a while back, a few months ago, where this group of epidemiologists looked at all the coronavirus data that they could find clinically. So MERS, SARS, and anything else they could get their hands on, and looked back to 1985. And they found that in all cases, there was good evidence to suggest that the immunity that was developed or acquired was not long lasting. So it all fits. So I would not rely on antibodies. So that's step number one. Step number two, there's another arm of the immune system that is not your antibodies, and that is your T cell response. The T cell response is different because now you're not generating antibodies, but your T cells, which are part of your kind of watchdogs, your sentinels, they're the guys who get infected by HIV, which is partially what makes HIV so effective. The T cells are kind of patrolling in your body to find foreign objects and attack them and remove them. They're basically your guards. And T cells have their own way of recognizing viruses. And there is evidence to suggest, although it's early days, that not only do we have an inherent built-in immunity to SARS-CoV-2 because of our T cells, and that's a big leap. We can say scientifically that the T cells respond to SARS-CoV-2, And that's from blood bank data. So blood banks that were stored before coronavirus came along. So we know that it wasn't because the person had been exposed to coronavirus. About 30% of those samples already have some reaction to coronavirus from the T cells. And we think that that is because of, remember I said that 20, 30% of the cold, the common cold, is some relative of coronavirus, that has given us that sort of lingering background response to corona. I'm hesitant to say that it's immunity because we don't know that, but it responds to it. And people who've had coronavirus or COVID-19 and have donated blood, and T cells have been isolated from that blood, over 80% of them have had a pretty significant response to corona. So there is reason to be optimistic that if you are going to develop immunity, it's going to be T cell based rather than antibody based. So you could say, well, okay, that's great. Now we can have people give a blood sample, and we can do a T cell assay, just like you could do an antibody assay, and see if this person has immunity to COVID-19, and then they're free to operate on the film set. I wouldn't go there yet because we don't know. And that's why I said that the science is still out. So we don't have that information. It may be that that's the case. It may be that once you've had COVID-19, you cannot get it again because of your T cell response, not because of your antibody response. But we don't know that for a fact. So what is the solution? The solution, in my mind, is what Manji said, which is doing the RNA test. And basically, you have to do that frequently, because if you just do it once, you may be negative today, but you could be positive 4 days from now. So basically, the first thing is isolation. So you would have to put your whole film crew and film set and the caterers and the cleaning crew and everybody would have to be in a bubble. And that bubble would have to be isolated from the outside world. Ideally, if you could, you would put the bubble in a part of the world where they don't have a lot of coronavirus outbreaks, so not in the United States. And you would really be stringent in keeping that bubble isolated from the outside. And then everybody inside the bubble would be tested at least every 2 days, every 3 days, the way we do. And I said that small and large, so we've been doing this since March, and we have not had any transmission of coronavirus in the workplace because our workplace is a bubble where only people who are tested and tested 3 times a week are allowed to enter. So it worked on a small scale with us. And I know it's early days, but it looks so far like it's working for the National Hockey League, who have just done exactly this. So they have 2 hubs, one in Toronto, one in Edmonton, smart choice not to come to the United States. And in Canada, they have very low coronavirus incidence, especially in Edmonton. And they've locked it down, and they're testing everybody who's inside stays inside. So the bartenders, the cooks, the cleaners, the film guys, the sound guys, and the players and the coaches and the training staff and the doctors. And they're getting tested every day. And now we're, I think, two weeks into the bubble, and so far not a single positive, with thousands and thousands of tests run. So it looks like it's working extremely well. So that's the model that I would recommend. That is a model that I think, as far as from everything we know so far, is the safe and responsible way to have something like this. And I think it extends extremely well to the film industry because the film industry is a self-contained organism when you're on set, right? Everything is kind of a unit, and you could isolate that unit in theory.
In theory, yeah. If you were on location, you would just also have to extend that out to the where you're sleeping, basically the hotel. You'd have to extend that out, or they need to add berthing. That's what we call it in the military, to the studio lots. But I mean, a film is a month or 2, depending on the size of it, and then a TV series can be 6 months. So
when you cannot get that bubble or the isolation, you can increase the frequency of testing. So if somebody is at the set and they go home or somewhere, maybe they get exposed to, but that person would be picked up on the test at an early stage. So that way, the probability of that person coming and spreading on your stage is lower because you are doing more frequent testing.
I mean, the moment you open the bubble, then the problem is going to be that you got people wandering off, and then you don't know who has or hasn't left. And so, keeping, you brought up the example of the military, you know, running a military-like operation outside of the military for civilians is very challenging to enforce. So, um, just getting people to wear masks is hard enough as it is. And, that would be also, what we do, for example, is, our longest periods between tests is, leave on a Friday, we test Friday morning, then you're gone the whole weekend, and then you come in on Monday morning. Well, there's a chance that by Monday, 3 days later, that you're starting to have an expansion of the virus. If you were infected, say on Thursday afternoon, you would have been negative most likely on Friday morning, and the virus starts to grow over the weekend. And then by Monday morning, when you come in, you're positive and you're definitely shedding a lot of virus. And by the time we have the test results, so you would get tested Monday morning. In our system, you get the results early Monday afternoon. Well, by then you already infected everybody at work potentially, right? So what we now do is we require everybody to wear masks at work until we have the test results, and then then the masks come off, assuming everybody. So
So
so you could do
that's a
something like
decent compromise for it. Like, so
that.
until we
Exactly.
know, you have to wear it for a couple of hours until we get the results, and then you can go on about your day. What about the idea of potting, and instead of
Yeah. So pooling of samples is something that has been talked about. It's actually a very common approach for infectious disease monitoring because oftentimes testing is limited. Um, I'm not a big fan of it, only because there are a lot of technical issues associated with it. Um, for example, um, there are 4 classifications by the CDC for a test, an RNA test. So the PCR test, you can be positive or negative, which we all know what that means. You can be inconclusive, which means that we're not sure. We think we might have detected the virus, but it's not 100% sure. We have to retest. So it's not a false positive, false negative, because you know that something is not right, but it is a retest. And the last one, which is invalid, means that you haven't collected enough sample to be able to make a determination. So, for example, imagine you were cheating, kind of like a doping test, right? If you wanted to cheat and say, "I want to go to work today. I have to work, and I know that I'm not feeling well. Maybe I have it. I'll just wear my mask, and I'm gonna not take a sample. When they give me the swab, I'll just pretend I'm swabbing, but I'm not really swabbing, and I'll give it back." There is a check for that, which, because along with the 2 different parts of the genes of the virus that you're looking for that Manji explained, we also all measure the human RNA as well. So there's a human RNA control that is included in the test. So you're actually measuring 3 different things for every sample, and that human RNA will tell us, have you collected enough human material that if you do detect the virus, it means something. And if you don't detect the virus, it also means something. You have to have enough human material so that you can say, okay, if there were a virus there, we would have seen it. So the cheating wouldn't work. So the problem with pooling the samples, what if the 3 of us pool our samples together, but I didn't collect very well? I wasn't very aggressive when I collected my sample. Then mine would have been an invalid because there's not enough RNA there. But I can't tell because the 2 of you counteract my sample because they're all pooled together and all the RNAs mixed together. You can't tell which is the RNA from whom. So that's one problem. And then the other problem is one that maybe it's just one that we haven't figured out yet. But if you use the standard kits, the test kits, to do the extraction of the RNA, the first step, you get your sample, which has a whole bunch of junk in it from your nose, from your mouth, from your throat, or your stool, depending on where the sample was collected. There's all this other junk there, and you've got to clean it up and just bring out the RNA so that you can start analyzing the RNA, both from the human and from the virus. Well, in the cleaning up step, which is we call the RNA extraction step, um, you have a little column. It's a little pad, if you want, that you filter. You can imagine as a filter where you clean up the RNA, and that is a standard kit for RNA cleanup that you buy off the shelf. And it's the one that's approved by CLIA, by the FDA for emergency use. So this is the one that everybody uses, these very similar kits, to make sure that that you get valid results and that they're comparable among different groups. Well, unfortunately, when you when you pool samples, there is a risk of having too much human RNA there, because now you're adding samples from multiple people, and now you overload that little plug, the little filter, and your cleaning up isn't as efficient as it should be. So there is probably a good solution to that, but I don't think we're there yet. The compromise, because I know certain states that are very short of tests are pooling samples, and I think what they do is they dilute the samples before they do the extraction to get around this problem, and that is okay, because what they're doing then is saying, look, if somebody is infectious, they have to be producing a lot of virus, and therefore, even if we dilute, our methods are sensitive enough that if we detect the virus, if we don't detect virus, there's probably nothing infectious in any of these samples. And if we do detect it, it'll be there in high enough amounts for us to see. So pooling is definitely an option, because obviously, we're short on tests. So pooling is important. There is also, it makes it a little bit more complicated to manage the data and to tell people what the results are. Because and then you have to retest if there's a positive, and that's the other big problem. Is right now our positivity rate is very high, right? We're around 10% positivity rate. It fluctuates, depends where you are. That's really high. So you have to rerun a lot of samples. So for example, you imagine that if the positivity rate is 10%, and you pull samples from 10 people, most likely each one of these will come out as positive just by probability, right? And so
That's not good odds. That's not good odds.
And that means you're gonna have to rerun them all. So now you wasted a whole bunch of reagents.
It works well when it's a low positivity. And if you have a higher number, the chances you're going to redo them anyways. So it's a compromise, but it works well in certain conditions. Maybe for certain regions it will work well.
Okay. So when the pandemic first started, like in February and March, I think that had we been doing intense testing then with pooled samples, that would have been a really good approach, because then you can really identify the hotspots and lock them down early on. But we're way, way past that stage. European countries might be looking at that as an approach because their rates are very, very low. But on the other hand, they have a lot of testing. So, and this is not a political statement. It's purely the facts of where we are,
Yeah, I agree. I'm like, we just need to get through this. There's no undoing what has happened up until this point. It's more of how we can move forward. And the other question is, now that we are having a higher rate of infection, what's even with the mortality rate aside, what's the long-term life look like for those who have had it? And then if immunity doesn't last for very long, can someone get this 2-3 times and survive?
So this is again where I tell you that we know very little about the virus.
Okay.
But basically, the short of it is that there is anecdotal information of people becoming reinfected. And when you look at the actual clinical data, at least the ones that I've seen, they switch between nasal and oral testing. And so, for example, one person was positive orally, then was negative orally, and then the same day got tested nasally, was positive nasally, then was negative nasally, and then became positive again a few weeks later. To me, first of all, you can't compare oral and nasal. They're different compartments. And in different individuals, you will have more or less virus in one or the other. So we have found that for us, nasally seems to be the best all-around place to sample, and we're sticking with that. The other thing is, when you get the clinical test, it's typically not as sensitive as some of the research tests, like the one we do. And so you can be borderline negative but actually still be positive in terms of actually having virus there, but you get a negative clinical test result. If you were being tested by us, you probably would still be positive. And we've seen this. So in our paper that we just published, we had one person who was positive for at least 71 days. So, and towards the end, this person was close to being negative, but just lingered around just above positive. And then for a day or two might have even dipped down to negative and then came back again as positive. This person was not reinfected, but was just having a lingering low-grade viral infection. The virus most likely was still growing because it's unlikely that the viral RNA could hang around that long in the body. It would be broken down by bacteria and other human cells. So people talk about, having viral debris that sticks around for a long time, and that's what these tests are picking up. That's probably true for a few days, but not for weeks and weeks. That's very unlikely. So that's the positivity thing. So I don't think we have any clinical proof that you can become reinfected if you have been infected before. So when you say, well, Marc, you just told us that we have no immunity. I just said that the antibodies go away. Doesn't mean we don't have immunity. I think we may very well have T cell immunity and maybe even some antibody-based immunity, but the two are very difficult to correlate, right? You can't just take 100 people who've had the virus, recovered, are definitely negative by PCR at least for 2 weeks at a time, and then reinfect them with the virus to see what happens, right? We're not allowed to do those studies.
That's
not
not in this government. Maybe in an authoritarian place, but
there's this thing called ethics, and we just hard to get around. So yeah, these tests would not be achievable. But so we can say definitively, but it looks so far that once you've had it, the chances of you catching it again are unknown at this point. So the question is, what do we do going forward? Right? Was your question? How do we manage this? And I think that some of the public health guidelines that you're hearing are spot on. I think that's what we have to do. We have to be responsible, unselfish individuals by seeing that we're very fortunate where we are, where we're tested 3 times a week. Most people don't have that luxury, and so you have to assume that you're positive when you go out into the general population. And so by wearing a mask, washing your hands, and wearing a face shield if you can, and avoiding close contact with other people, which is hard to do when you're in a supermarket. But when you want to dive in and get your bottle of ketchup, wait till the person that's there moves out of the way rather than just squeezing in and diving out again. So these are the kinds of things that are obvious, that we all know, but are not being done. And one thing I can tell you, Adrian, that I would bet that if we all played by those simple rules for just a month or even less, the virus will be gone. It really is that simple. Unfortunately, we're unable to play by those rules, and it is it's not a criticism. It's just the reality, and it's difficult, right? I mean, wearing a mask is not pleasant, and you feel fine, and you're young, and you feel like, hey, I don't need to do this. That's for the old guys. But of course, it's not the reality. The reality is, again, you're the emitter. So if you're a young guy and you're asymptomatic and have no symptoms and feel great, but are shedding virus like crazy, you're infecting everybody around you. So now grandma gets sick and dies, right? So it's a question of being responsible. And that's the way to get through this in the short term. I think that there is a massive opportunity here for organizations to put together bubble scenarios. So if you're in the film industry, a company that actually would create bubbles that would provide the testing, the infrastructure, so that you can safely operate within this bubble, which may be a forest somewhere, with its own cabins and accommodations and kitchens and everything else, but it's isolated. You can't get in, you can't get out, and while you're there, you're being tested all the time. I think that is a very good business opportunity right now. Testing. Every lab that has a qPCR instrument, a scientist who knows, or a technician who knows how to run the test, they should be testing. They should be getting a Klio license and testing. We have all these universities that have labs full of the right equipment, a lot of graduate students who are very able to run those tests. I don't understand why they're not getting Clio certified and testing, at least for outsiders, if not for themselves. And I saw last night on the news, I was very happy to see, I believe it's the University of Kansas that is doing that. They're going to be testing like 13,000 people a day. And that is exactly what all the other schools should be doing. We have this incredible wealth of equipment and capable hands that should be operationalized. So again, Adrian, it's coming back to your analogy with the military. I think there is a lot the military could do as well to help set up testing sites. If we can get for-profit testing going fast enough, because these analytical labs have been really lingering behind. Let's get the military involved. They have a lot of people who could be doing testing. They can get Clio certified very quickly. They're very good at following protocol. They're very good at logistics. Now you could double or triple the testing that we have. These are all things that we could be doing and should be doing, because at the end of the day, testing is not a stigma. It's not a political statement. It is just a way of being able to understand and govern yourself in the appropriate fashion once you know what your result is.
So add to the question about how we live with it long term. What Marc was saying, wearing the mask and be conscientious. So I would say it's just common sense and patience. So you may be wearing a mask at the grocery store, but so you are touching certain surfaces which may be exposed, and we could have viral particles in there. So you are not going to get infected through the skin on your fingers, but you come to your car or you go home, you take the mask off, then you have this need to scratch your face or touch your nose. Now we are actually taking that particle that was on the ketchup bottle and putting it in your nose. So you have to be conscientious and just common sense. Come home, wash your hands. If you have access to hand sanitizer, have a bottle in your car. It's very simple steps. When you come to the car, have that patience. Take like 5 seconds. Don't touch anything. First clean your hands and then take your mask off. Otherwise, you are pretty much taking what's on the grocery store or any other surface and putting it inside your nose. So
I'm just imagining you saying this and trying to explain it to a child, and like trying to get kids to not put their hands in their mouths and the whole nine. Like,
and that's a good reason not to take the kids to the supermarket, right?
Yeah, the other reason, and schools.
Adrian, I know that we didn't answer another part of your question, which I know is a very important one. I will briefly answer it because there really isn't an answer, and that is the long-term effects of having had COVID-19. What is your life going to be like down the road? Well, that is a challenging one. It is the novel coronavirus for a reason. We really don't know what the long-term effects are. For some people, you may have nothing at all. You may never develop symptoms, and you may never have any consequences. You may have had what you think is a bad cold or a flu, and you never have any consequences from that. Other people have had major lung damage. They've had kidney problems. They've had cardiovascular problems, neurological problems. Pretty much anything you can imagine potentially can happen as a result of getting COVID-19. I don't want to freak people out. That's the minority of the cases, not the majority. But it is a lot of people who also are very healthy, very young. There was a young woman the other day who had to have a double lung replacement because of the lung damage she got from COVID-19. So this is not a old people's disease. Let's not kid ourselves. There are plenty of young individuals whose lives are ending much too soon, or who are developing long-term problems as a result of having had COVID-19. All the more reason to take this thing very, very seriously, no matter how old you are. And children, we don't know, because the whole talk about children not getting it or not being infectious was all based on epidemiological data that is completely flawed, because the first thing that happens during an epidemic like this is the schools get closed and the kids are locked down at home. So yeah, of course, they're not going to get it, right? Now we're seeing, as things are opening up again and we have more information, that kids absolutely get it. And especially um, the older kids, because they've been out and about much more, suffer from it just as much as adults do. There have been cases of children dying. They've been definitely, they spread the disease as much as an adult, even if there is asymptomatic. The other day, there was a report on a baby getting COVID-19, and there's been several reports now, but now we have actually a newborn who got it potentially from the hospital after the mother gave birth. So, I mean, there is no age limit to this, young or old. And the consequences of having it, obviously, if you've had it, your doctor should know about it. And the best thing you can do is monitor over time. And as we get more information, unfortunately, we've had nearly 5 million people in the US who've had it, or over 5 million now. I forgot the numbers, they changed so quickly. Uh, so we've had millions of people here in the US who've had COVID-19, and so we'll have, unfortunately, a lot of data as to what happens down the road. And I think that there will be a need in many cases for long-term monitoring, and then you'll be able to triage and say, okay, you've stabilized and you've had none of the indicators, and there's probably biomarkers that will be developed as time goes by to be able to follow your risk of developing a neurological or other problem as a result of COVID-19. But that's unfortunately where we are. It's not the flu. You do not just for the most people do recover, but there are a lot of people who don't.
And to add to the school children in whole, now with other countries opening up after dealing with the COVID situation, you get more numbers, like 20-30% of children who got exposed to COVID, now they have these immune disorders. They have these multi-systems inflammatory disorders. That means your heart is inflamed, or your kidneys, or your certain vital organs in your bodies. They have these immune responses. So it's not, they are not getting infected, that there's no damage to those kids. So we are just generating that data. So it's kind of not smart to just expose them. Even like, why do that? We don't know that yet for sure that it is not. So you can learn from rest of the world as well, not just to do the experiment or not just to go by the numbers here, because we are still in a lockdown. So the kids are not getting exposed to that level where the adults are getting exposed.
It's an enormous risk that I think any parent, I'm not a parent, but any parent I would have thought would think twice if they had the right information before they exposed their children and themselves to that risk. I mean, if you break down the numbers, and that's unfortunately what a lot of people go by, is statistics, and you say, well, only X percent of children will die from this, and it's a very small number. And then you suddenly say, okay, in my school district, how many children does that equate to? Oh, it's 87 kids. Oh my God. So let's choose which 87 kids should be essentially die because we're not taking the adequate precautions. That becomes much more tangible at that point. And when you realize that some of your children's friends will die of this, most likely, if there is an uncontrolled opening of everything, it hits home, even though the numbers themselves seem like they're very small. And it's like, yeah, well, that's a risk we can take. It's not. I mean, I think that when you're dealing with people's lives, obviously you can't shut the whole country down because of the common cold, because 0.003% of people die of it, or whatever the numbers are. I understand that, but this is not the common cold. This is not the flu. This has definitely got a much bigger price tag in terms of human life associated with it, young or old.
On that happy note, I just would like to reiterate thank you so much for coming out here, and that world, if we just followed the guidelines for 2 weeks, 1 month, maybe 6 weeks, if we had just followed the rules the first time around, we can try it again now. We'll be done with this and we can go back to normal. New Zealand is having maskless rugby tournaments. Full on life has returned in New Zealand, and we can have that too. But we have to work as a team. We're all in this together. And if there's that one person in the group project who is not doing their part, we're all going to fail. So I don't know if that's a great, happy way to end this, but it's the best I could come up with. But once again, thank you guys so much for coming on board and as well as being our medical advisory board for Klio Studio, because I really am looking at how do we specifically take real data, real information, and then turn it into a solution to at least try to get a large sector in California and a very important morality sector for the United States back to work. And so once again, thank you for everything else. I will put up the link to your paper as well as to your research facility. Is there anything else you want me to make available for anyone who's interested in maybe getting in contact with you, asking more questions, or anything a link or anything you think I should put up for everyone?
No, just to our website. They can find us on the website, and our email addresses are there. So feel free to contact us with any questions. And thank you very much for having us. It's great to be able to share some of this information, because information is everything, right?
Yes, correct, accurate information is everything. All right, thanks, guys.
Thank you. Bye-bye.
In Hollywood, they say it's who you know, not what you know. We disagree. Tune in next time for another epic story. To be continued.